The purpose of this YouTube video is to demonstrate how to connect an Arduino to a breadboard containing a potentiometer, an ultrasonic sensor, and a 16:2 LCD to measure and display the distance an object is from the sensor. The description will include the coding, the components needed for the project, along with some reasons the project may not be working. Credit will be given to references used for this project. The components include an Arduino board, a breadboard, a microactivity 16:2 LCD, or any HD 44780 compatible LCD, a potentiometer, an ultrasonic sensor distributed by SainSmart. The LCD and the ultrasonic sensor were purchased from Amazon, and the other components were included in a starter kit purchased from Newegg. The video shows an object about 3 inches from the ultrasonic sensor as displayed on the LCD. The measurement displayed on the LCD changes as the object is moved closer or further away. Step 1 is to wire the LCD backlight. Connect pin 15 of the LCD to a 330 ohm resistor and then to the Arduino 5-volt power supply. Attach pin 16 of the LCD to the Arduino ground. Step 2 is to wire the LCD data pins. LCD D7, which is pin 14, is attached to the Arduino pin 2. LCD D6 pin 13 is attached to Arduino pin 3. Connect LCD D5 pin 12 to Arduino pin 4 and LCD D4 pin 11 to the Arduino. The LCD is powered by connecting pin 1, known as VSS, to the Arduino ground, and pin 2 of the LCD, labeled VDD, to the Arduino's 5-volt. Also connect pin 5, which is the read-write register for the LCD, to the ground of the Arduino. Grounding pin 5 places the LCD permanently in write mode. Continue to wire the LCD by connecting LCD pin 4 labeled RS to Arduino pin 12 and connecting LCD pin 6 labeled E to Arduino pin 11. The next step is to attach a potentiometer. A potentiometer is a 3-terminal resistor with a rotating knob that forms an adjustable voltage divider. The middle leg, known as the wiper, is connected to the 3rd pin, or the VO pin of LCD. The left leg of the potentiometer is connected to the positive terminal of the Arduino, and the right leg of the potentiometer is connected to the ground. This step completes the wiring of the LCD. You may be asking yourself why the LCD pins D0 through D3 are not connected. The reason will be explained in the next slide. This slide gives a brief explanation of the purpose of each of the 16 LCD pins. Pin 1 is the cathode and pin 2 is the anode. These 2 pins complete the power circuit for the LCD. VO pin 3 is connected to the wiper pin of the potentiometer to allow adjustment of the contrast. Register select is pin 4 of the LCD. This register determines whether the unit is to receive a command or receive a character. When the register is low, meaning no volts, the unit is ready to receive a command, such as to clear the display or set the cursor to a given position. When the register is high, or 5 volts, the unit is ready to receive a character from the Arduino. RW pin 5 is connected to the ground of the Arduino. This low setting permanently sets the register to write mode. This project does not require any data to be read from the LCD. E for enable is pin 6. If this register is low, then the Arduino knows to wait before sending any signals to the other registers. D0 through D7, pins 7 through 14 are data pins. Display characters are for extended ASCII characters. Modern devices use 8 bits to display characters. For example, the capital letter P is represented in binary as 01010000. Why are pins D0 through D3 not used? The routine built into the Arduino library, known as liquid crystal, is the reason. The liquid crystal routine sends ASCII codes not in 8 bits, but in 4-bit bursts. 8 bits are eventually transmitted, but only in 2 bursts of 4 bits each. The first 4 bits, called a nibble, are sent followed by the next 4-bit nibble. The 2 nibbles are combined to make the 8-bit ASCII character. Step 6 is to wire the ultrasonic sensor. The ultrasonic sensor has 4 legs. The left leg is the ground, as shown. Next to the ground is the echo pin. The echo pin is connected to Arduino pin 10. Next to the echo pin is the tring pin. The tring is connected to Arduino pin 13. The right leg is VCC and is connected to the positive lead. The ultrasonic sensor emits a ping at 40,000 Hz. If there is an object or obstacle in its path, the ping will bounce back to the module. Considering the travel time and speed of the sound, the distance can be calculated. The ultrasonic sensor has 4 pins. The VCC and the ground pins are connected to the 5-volt and ground of the Arduino. The tring emits the signal and the echo is a receiver. The tring and echo pins are connected to the Arduino. A potentiometer is a 3-terminal resistor with a rotating knob that forms an adjustable voltage divider. The middle connector is known as the wiper, which acts as a variable resistor or rheostat. The wiper is connected to the VO, or the 3rd pin of the LCD, to control the contrast. The following code was copied from Paul McWhorter's website. The credit for the link is listed on this slide. The first line of code loads the liquid crystal library. The second line of code creates a liquid crystal object called LCD, and the numbers listed are the pins on the Arduino that are to be connected. Liquid crystal library handles communication between the LCD and the Arduino. Liquid crystal expects the Arduino pin 12 and LCD pin 4 RS for register select to be connected. Liquid crystal also expects Arduino pin 11 and LCD pin 6 E for enable to be connected. The routine checks the enable pin to see if the LCD can receive characters. If the value is low, then LCD is able to receive data and sends characters to register select. I am new to the Arduino world. As a novice, I encountered a number of challenges. I discovered that not all breadboards are the same. According to the example in this slide, the rows for anode and cathode are continuously connected. On the board I own, I had to bridge between the gaps for them to be connected. If you're having problems getting your project to work, the breadboard may be a reason. Soldering was a challenge for this 70-year-old. To solder the head pins to the LCD, I used my old soldering iron, which was a big mistake. The old iron tip was too large and the iron was too hot. I either had too much solder on the pin or not enough. These old eyes have trouble seeing. I invested in a new soldering iron with a smaller tip, as well as a helping hand magnifier soldering station. I experimented with different temperatures for the iron. A temperature of 300 degrees worked well. Calvin from Sunfounder gave a wonderful presentation on how to solder. The link for the YouTube video is given below. If you're looking closely at the picture of the LCD I soldered, you can see what a poor job I did. I have since learned to solder header pins that look decent. Because I struggle with soldering the header pins to the LCD, I found this helpful reference on the web. that lets you determine if the LCD is working. I purchased an inexpensive soldering iron and helping hands magnifier from Amazon. Both items were good enough for me. The jumper wires that were included in the starter kit I purchased were of poor quality. I purchased a hookup wire kit, solid wire 22 gauge, 6 25-foot spools from Walmart. I also purchased a 12-drawer storage organizer from Harbor Freight for $8.95 to help me keep the ever-growing component parts orderly. In closing, I want to mention a couple other stumbling blocks that prevents this project from working. The Arduino and breadboard are small. It's very easy to wire the components incorrectly. Even when I've double-checked the wiring, I still made mistakes. A handheld magnifying glass and tilting the boards to get the right angle helped with alignment. Another stumbling block I have yet to figure out is worthy of mention. I initially used Microsoft Word to type my code and then copy the code from Word to the Arduino environment interface. There was no mistake in the code I copied, but when I verified, the Arduino compiler gave me an error. If I typed the same code into the Arduino interface, there was no error. I still do not know as to why this would be the case. My best guess is there are some hidden control codes in Word that were transferred in the copy. These codes are not visible on either application. If you are a novice like me and want to learn more about building Arduino projects, I highly recommend Paul McWhorter's instructional series. I would recommend also to test your wiring configuration and code using Tinkercad circuits before wiring, as it will save you a great deal of time. I hope you found this YouTube video helpful.